Hi, I'm Kim Sampao, Director of Communications for ECEDHA, and it is my pleasure to introduce Andy Mastronardi, who is the Global Director of University Programs with Freescale. Andy?
It's still morning. Good morning to everybody. So my background is not in engineering. I'm a mathematics and chemistry major. And I've been in education all my career, which is probably about close to 40 years now. So I've worked with all different levels, everything from elementary school, taught at high school, taught at college, actually at New Paltz. I taught there for about 3 or 4 semesters. So anyway, what I want to talk to you today about is the Freescale Cup. And the Freescale Cup is a robotics competition we do. But before I do that, I talked to a few people last evening when I was here, and they weren't that familiar with Freescale or our history. And so I thought maybe I'd just have a couple slides on who we are, what we do, before I get into the university programs, and then specifically the Freescale Cup. So, for you that don't know, we used to be part of Motorola. We used to be the semiconductor component of Motorola. So we built all the chips and all the processors and controllers and everything that went into their cellular phones, their PDAs, and everything else that they did. And about 6 or 7 years ago, they spun us off as a separate company, the name Freescale. And the advantage for Motorola was we were a cost center for them. They could still work with us, but they didn't have that cost center. So it was very, very good for them. And then for Freescale, as a separate company, it was good for us because we could work with other people as well. So that's kind of a little bit of our history. So today, we're more than just an embedded processing company. We're actually into more solutions types of things. So we have 2 core groups in our corporation. One is the automotive, industrial, and multi-market solutions, which involves the controllers, sensors, and analog devices. And our other division is the networking and multimedia solutions group, which is the communication processors, application processors, RF power. And we are involved in 4 primary markets: automotive, industrial, networking, and consumer. And you can see on that diagram over to the left, your right, is the core of it is the embedded processing piece. And then we have sensors and sensor technology, connectivity, where that means RF, Wi-Fi, and all the other protocols, control, analog, and then software ties it all together. So when we go in to visit our customers, we're talking all these elements all mixed together as a solution. So we have over a 50-year legacy products. Many of you probably know the old Motorola products, HC11, HC05, and 08, and all the way up to, we have 5,500 today, over 5,500 engineers in our corporation, 20,000, around 20,000, 21,000 employees around the world. We have over 6,000 patent families, and then we work with over 18,000 customers globally. The 3 trends that we kind of work a lot of our products around are very similar to probably what you've seen in other companies: going green, health and safety, connected intelligence. So in going green, we're talking about power modes, battery storage, things like that, where we're optimizing power. And then also we're trying to take a lot of our curriculum that we're developing and all our documentation and moving it online, get away from the paper trail. In the health and safety, we're talking about sensor integration. So everything from people wearing vests that have sensor on them, or to fault tolerance or preventative safety. This is a big area for us. It's not just airbags now in cars. We're talking about things where sensors are on vehicles that prevent accidents from happening. And then connected intelligence. This is the Wi-Fi I mentioned before, RF, USB connectivity, and graphical user interface when you're talking about the software side. So let me get into the university programs and what we do. University programs basically has three buckets. It has an education component, it has a careers, and a research. My particular charter, my principal charter is education. While I work with the R&D in the research area as well as the careers, my principal job is education. So let me just go to the careers and research first. In the careers, obviously, we have internship programs. We have an engineering rotation program where people can come in and they can rotate through 3 or 4 different groups within Freescale to identify what they like about the business of embedded systems. And then employment, obviously, we hire right out of school, mostly PhD and master's students. In some cases, in different parts of the region, we look at undergraduate as well. They have different dynamics to the business. On the research side, you heard Ken yesterday, if you were here last evening, Ken Hansen, who's our CTO. We're business driven. So what I mean by that is that our business groups that have needs for research, that's where the research comes in, and it goes into mostly the SRC, the Semiconductor Research Consortia. And then we also work with universities on a selective one-on-one basis if there's a particular project that we want to get up and going. On the education side, we focus in courses of study. So we have hardware and software tools, branded labs and courseware, and I'll get into these as we go further. Student projects, we do sponsorship, tools, donations, and recognition. And in the competitions, we have the Freescale Cup, these advanced vehicle technology type of competitions, and also STEM initiatives at the 6 through 12 area. Hardware and software tools. So let's talk a few minutes about that. So we started out with a platform on the bottom left there, the project board. It was something that was designed for education. It has a large proto area, and it's more of a hands-on type of environment. So we put all the things on there you'd experience in an integrated circuit course, or we wanted to teach microcontrollers, things that were kind of at the low end as a basic function type of teaching tool. And we teamed up with National Instruments, and we designed it in a way that we could also plug it into NI Elvis and take advantage of looking at modulation, wavelength, all those different things that you can with the NI suite of tools. The other thing that was nice about it is that on that particular board, there was no controller. So we developed all these little modules, everything from 8-bit, 16-bit, 32-bit, coal-fire, and we have maybe a half a dozen modules that plug directly into the MCU connector on the board. So you could use multiple controllers, and as students became more and more familiar with our processors, they could graduate to a little bit more complex architecture. The platform up on the upper right there is called the Tara Systems. This is one of our newer systems. It's probably been out for about a year and a half, and it's a modular system as well, but it's a little bit more compact, and it has 4 levels, what we call those vertical walls or elevators. They have basically 4 connectors, PCI edge connectors, that will host a series of modules, whether there be controller modules, processor modules, or peripheral, things like memory, things like sensor cards, all these different things that you can plug and play all over this, as well as an LCD display that you can put on the side. It even has a connector on the side, and these are all have the same pin configuration. So you can switch out and you can add on, and students can really develop any kind of application in any area they want to go. And it's a very, very low cost. I think that the basic module of a tower is somewhere in the neighborhood of $100 to $115, somewhere in that range, that you can buy it all. And that comes with an MCU card and basically a communications card with USB and other communications on it. Branded labs. This is another level of how we work with universities. What we do is we go into universities and if they really want to adopt the Freescale technology, we want to make it more of a partnership. And so what we do is we offer to go in and sort of brand the lab and put our signage on the lab, and in exchange we would do a donation of tools into that lab and help them just build everything around that, help them with the curriculum. Also, we would help them with training, so we could bring in our industry customers in the area, and at the same time when we train the educators and students, we can train the industry as well. So we build these synergies up for the university between their students and the customers that they probably will be going into, or a majority of them will be going into. So it's a really nice way that we work with universities, and we're becoming more and more. Right today, we have probably in the neighborhood about 230 to 240 of these labs around the world that we work one-on-one with these partnerships. Our courseware offerings come in a number of different ways that we do them. Once again, remember I mentioned about trying to go more online and try to get away from paper. We developed these, what they call like a POGL module, and it's a process-oriented guided inquiry approach. And these are kind of mini lab type of structure where we teach concepts that you'll be teaching in a microcontroller or an embedded systems course or things along those lines. And we have a series of modules. You can see up there we have S12, 2 different families, coal-fire, which is the 32-bit processor. And also we're working on Kinetis now, which is an ARM-based processor. And we're developing those, and that's coming soon. We're working with the university developing those. And these are all developed from within academia. These are not an engineer designing these, so they're really relevant, and I think that they're well done and they fit the curricula really well. We also offer university author materials that come into us, so people are working with our technologies in our branded labs or other places that they develop teacher notes, labs, whatever else you have in the way of courseware, and they share them with us, and we post them on our website and build sort of like a database of resources for people that want to move into our technologies or move into a different family, and they can do that fairly easy. Textbooks, we recommend all. We don't have any textbooks that we have internal to our company, but we work with all different publishers that we have books that are written on our process as well. And then on-demand training is we go out and do training at sites. We also do things like designing with Freescale series. This year, I think we have around 300 that we're doing around the world, where we actually pick sites where our customers are, and we invite our customers to come in for training on certain technology. We have different types of ones. We have designing with Freescale with just a generic type that goes across all our different types of technologies for exposure. And we also have focused ones that maybe that you have automotive area that we do. But we also invite educators and students to attend those as well. Student projects, real quick, here's a couple projects we did. This the first one on the left there is one we did at RIT last year. It has to do with a tower system where they took it and created an e-health system. And the one on the right is an I.MX, which is our ARM-based tools, pretty high level, that for center stack development in a car. And that one there, it shows you the LCD display as well as the board. And we have a demo actually at our booth, and you can take a look at that later. So let me get into the Freescale Cup here. The Freescale Cup is more than just a competition. We see it as a platform for teaching. This has evolved. It started out in Korea probably 7 years ago and has moved into China, Malaysia, India, and Asia. We also have it in Europe, Brazil, Mexico, the U.S. We have it all over the world now. And what they're doing is it started as a competition, but it's starting to work its way back into the curriculum. So they use it as a platform to teach senior project classes. So students build this. There's more of a competitive aspect about it, which really motivates these students to want to do more. It's an opportunity to learn not only electrical engineering, circuitry, interfacing, and software, but you just don't learn about the controller, but you learn how it interfaces with a camera, how it interfaces with a servo, how it interfaces with the H-bridge, the motors. And what you get is you get a system approach, and these students are learning a lot more through this platform. People have actually brought it and teach their microcontroller class with it, or a robotics type of course using this. And they sharpen their communication. Team skill works at the same time. So they get that not only the hard side where they're learning the engineering component, but they're also learning about the problem-solving aspect and the collaboration with other students. They get an opportunity to apply it. So students apply their knowledge that they learn on the embedded systems. Students share their work with other teammates. And students are persistent to overcome the challenge. This whole motivation aspect of the Freescale Cup is really something that I think we need to see a lot more in education. These students need to get a lot more about getting excited and passionate, that we don't lose them to other disciplines, that they stay in the electrical engineering, computer engineering, or even mechanical. They compete. We have competitions all over the world. So this is one last year in China that we did. In China, they had 15,000 students trained on this platform, and there were 2,000 teams of 3 students that raced in China last year. And just very, very powerful and very exciting to watch. The cycle of the Freescale Cup can be matched up with your curriculum. It can go anywhere from a semester course all the way up to a full year, from 1 month to 8 months, and you can condense as much. I would say that the minimum amount of time for this would be 4 months, so it'd probably be a semester course would be probably the ample time or the minimal time that you could do this competition. This is what the kit looks like when it comes to you. It's a kit where the students assemble a lot of it. Comes with a processor board, comes with a camera. It has the servo for driving, so it's a complete kit, and it's offered on our website in 2 different packages. Either you can buy it with it's a power architecture board we have right now, or you can actually buy the kit without an MCU card, and you can use whatever you like in there. So if you want to use an 8-bit or 16-bit, or we're building the tower system now that goes into the car as well, so you can pick and choose what you want. This is the power architecture board. I don't think I have to go into details about that. It's a 32-bit. It's a modular track, so we actually have the kits that you can break up into different things, so you can build the track as large as you want or make it as small as you want according to the complexity and the level of students you're doing with. So for the advanced students, you might want to put a hill in there. We put some crisscrosses, we put some really sharp curves, and these people follow that black line around the track for speed. You could take it even further. You could take it where you're actually doing more with that same chassis. This student here put some accelerometers on it and went around the room on 2 wheels balancing. So it's a platform that you can do a lot with. Real quick here, Freescale University programs overview. If you want to see all our programs and what we do in the university programs, Street Smarts is our forum for students and faculty to come in there, and actually we created a wiki which you can come in, and as it keeps on growing, as students do experience things, they share it with other students. So it's a really, really nice community, and we have tons and tons of training. We have everything from videos to printed documentation to everything on to support that competition. So with that, I think I have about a minute left. If anyone has a quick question, I'll be glad to answer it. And if you think of something later, you're welcome to come over to the booth and look at some of the demos we have there, as well as talk a little bit more about the Freescale Cup. Yes, sir.
This idea of having these cars move along stripes has been around for a long time. Are there any dramatically different variations of tasks that you
Well, like I said, I think you could take the competition to any level you want. You can add complexity to it. We have an innovation level that students can actually compete and take that. So if you were gonna, you can give a theme of maybe like a rotary, and maybe you'd have 3 or 4 cars that they build, and have them come in, entering and exiting the rotary, for example. You can build that and put some sensors on that so it would stop when another car comes by, things like that. Or you can have a disaster drill where, you know, maybe a bridge is out and you can have the car come up and how to get over that bridge that's gone out. So, I mean, you can take the chassis and do lots with it and make it as complex as you want or as simple as you want. Anything else? Okay, well, thank you very much for your time. Appreciate it. I know everybody's starting to get hungry, but thanks again.